Hey guys, how you doing? Lately in math, we've been talking about prime factors. Today I'm going to go over an example of how you would do a prime factorization tree. Let's say, for example, that we have the number 32. I can think of a couple ways to make the number 32. One comes to mind is 8 times 2. In 5th grade, we don't use the x anymore, and we'll get into that later, so I use a dot. 8 times 2. Or excuse me, 8 times 4. Now, I know 8 is an even number, and I know 4 is an even number. That's one of the ways that I can determine that 8 and 4 are prime, because I know they're divisible by 2. So, if I want to break 8 down, I know 8 can be broken down into 8 times 2. And 4 can be broken down into 2 times 2. Now, 2 is a prime number because the only way to make 2 is 1 times 2. So I cannot break that number down anymore. But I can do something to 4. So I'm going to break it down. And that number will break down into 2 times 2 as well. Of course, those numbers can't be broken down. So, I have my prime factors of 32. I have 2 times 2 times 2 times 2 times 2. And if I did it correctly, this answer should equal 32. Let's see if it does. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. So, now here's a weird thing that's going to come up. And we're going to talk about this. Since I had the number 2, it occurred 1, 2, 3, 4, 5 times. I could say that's 2 to the 5th power. That means 2 times itself 5 times equals 32. Some people call this a power. In my class, we're going to call it an exponent. And we're going to get into that a little bit more. But anytime you have a number that repeats itself, like the number 2, and you multiply it times itself so many times, that would be a power or an exponent. And of course, this is all from 32, the prime factorization tree.